In example 2, we want to determine if these statements are always, sometimes, or never true based on our postulates. So the first one, the intersection of 3 planes is a line. The intersection of 2 planes is a line. So I could have 3 planes intersected in 2 lines. 2 lines could intersect in a point. So I'm going to say sometimes. It could be true. All 3 planes could intersect in the same line, but they could also intersect in a point. So we're going to say 2 planes. Let me rewrite that. 2 planes intersect in a line. If we add in the third line, it could be another line, or it could not be another line. Could be 2 lines, and those 2 lines could be parallel, or those 2 lines could be, or it could be the same line. Okay, now let's take a look at line R contains only point P. And once again, that's not sometimes true, that's never true. We said a line must have at least 2 points. So it can't just be 1. You can have more than 2 points, but you have to have 2 points. Now, our third one says through H and K there's exactly 1 line. That's our very first postulate we looked at, isn't it? That's postulate 3.1, which says pretty much what we just said here. It says well, let's take a look at it together. How about that, instead of me guessing? So through any 2 points, there's exactly 1 line. Now, postulates that we talked about, these first 7 postulates we did, those are like our rules in geometry. They're saying, hey, why is that true? Because we said so. Definition kind of goes the same way. We defined it, so we accepted that to be true. Now, a proof is something we're showing that's true. Either we've done it or somebody else has done it. Like Fermat's last theorem we talked about in the beginning here. We're not going to do that in geometry because it's actually two pages or 2 different articles by this person from 1995, but we know it's true. Somebody else has proved it, so we're going to say, hey, I can say that. I can say that anything beyond 2 is the Pythagorean theorem or something like the Pythagorean theorem doesn't work. A to the n plus b to the n will never equal c to the n with whole numbers. Obviously, that will be true with decimals, but not with whole numbers. Now, here's what we're going to do to write a proof. Not want to hear any complaining, because you can do the first step always. Always write down what you have. If they don't give you a picture, draw that picture out. Let me change colors. I don't like that. Okay. Then we're going to, this is the part that can be kind of confusing. And so we're not going to do all of this step today. We're going to use deductive reasoning. We're going to say, what do I know because of that? And tell me why I know that. The why part is justifying. And then I should end with what I was asked to prove. So you know the first step. You know the last step. You might not know the reasons, and then the proof is going to take you from the beginning to the end. So it's a process to do a proof.